Hi, everybody, and welcome back. So we had just talked about doing string matching, and the things that the two functions that we had learned was string detect and string count. So string detect says, does this pattern or the reverse of this pattern show up in a string? And when I say reverse of this pattern, it's does this pattern show up in the string or does this pattern not show up in the string? And then the other function that we learned was the string count pattern, and that is the string count function, and that is how many times does this pattern appear in a string. Now, for modifying strings, a couple of different functions. Really, what we're going to be focusing on is these four down here. It's very rare that I use string replace and not string replace all, or string remove and not string remove all. Most of the time, if I want to replace or remove something, I want to remove all of them from that character string, and string replace and string removes only the first. Um, I guess there would be a scenario where I'd only want to remove the first one. I mean, there's a reason these functions exist. So someone needed it. But I personally haven't used them very often, and most of the time I'm using either if I'm replacing or removing, I'm using string replace all or string remove all. So string replace all is going to find all of the matches in a particular character string and replace them with a different match, replace them with something else. String remove is going to do the exact same thing, but the replacement is going to be the empty character string. And when I say it's doing the exact same thing, I mean that string remove all is literally just a wrapper for string replace all, where the replacement is just the empty character string. So anyway, and the other functions, these are also super helpful. The string to lower and string to upper functions, and then there's also like string to title and string to sentence or something else like that. But basically what you're going to do is you're going to most of the time use string to lower and basically turn your entire character string lowercase. There are a few times where I've used string to upper, and that would be like if I have state abbreviations or something where someone typed capital F lowercase l, or capital A lowercase r, or capital T lowercase x, or something like that. And I know that the two-letter state abbreviations are all uppercase, then I've used string to upper. But most of the time, I'm using string to lower to just say, let's get rid of all of the cases because R is already case sensitive. We don't need to be dealing with trying to do case sensitive code like string matching. It's just a pain. So, all right, let's dive in. Let's look at string replace all, and let's say that for whatever reason, we're in this scenario where we want to make it easier for people to see the vowels. Perhaps they're learning English as one of their additional languages, and we want to say, okay, we want to give you a list of all of these words where we've highlighted the vowels. And so we would say, all right, let's take the fruit. And then the first thing we're going to do is we're going to replace all the lowercase a's with capital A's. Then, so here's our pipe operator again, and then replace all the lowercase e's with capital E's, and then all the way down. And so notice here a couple of things. Number one, order matters, all right? And this means if I had done a more complicated string replacement up above, if I said, okay, replace A-E-I-O-U with something else or whatever, then the lowercase E-I-O and U down here wouldn't exist anymore because they had already been replaced by something else. So this is one of the reasons why running things in a pipeline is very important, because you can check it step by step. And so you say, okay, well, I'm going to first run this part of the pipeline and check to make sure it's doing what I want to do. Then I add on and say, okay, go back and highlight the 3 rows, and then check that, and then check the next, and then check the next, and then check the next. I really recommend that you do that with string manipulation, because there's so many ways for things to go weird that you don't expect. Okay, so think about this. Whenever you're working with strings, there are 26 letters in the English alphabet, and then that's just the lowercase letters. There's also 26 uppercase letters in the English alphabet. There's also all of the symbols in the English alphabet. And then that's only one position at a time. Once you get into string matching where you say, okay, give me things that match two characters next to each other. Now all of a sudden I've got there's like 100 something different a combination that could be in the first position, and then another 100 that could be in the second position. So I've got basically like so many 2,000 combinations or whatever that could be in the first two positions. Like, well, maybe maybe the first one's a space, then the second one's a lowercase a, or the first one's a dot, and then the second one's a closed parenthesis or something like that. So there's just so many ways that things can get complex. And a lot of times we're not used to that. We're not used to thinking through the complexities of string matching. So just be aware of this and use a pipeline to go through things step by step to make abundantly sure that what you're doing is what you actually want to do. All right. So here's an exercise for you. So go back into this outcomes data set, and the asterisk symbol represents the times where a patient came back to the clinic and they had multiple different urine samples during that week. And some of the urine samples were positive for the substance, some of the urine samples were negative for the substance within that week. So this represents a mixture of signals. A lot of clinical trials will say, okay, well, if there's ever a week where there's a mix, where there's some positive urine and some negative urine, we're just going to count it all as positive for that substance. Okay, so read how to escape symbols and then do this exercise. Okay, so I'm going to pause here. Okay, so you've had a little while to work on this exercise. Make sure that you have talked this over with some of your partners, colleagues, other fellow students, and so forth. All right, so now we're going to get into an example where I said, number one, order matters, and things do, like the string matching does things that a lot of times you don't expect, okay? So right here, there's something called, whenever you're dealing with character strings in a sentence, so if you've got dictated data or you've got free text notes from, like a lot of times there's structured or unstructured interviews with patients or with participants, you end up with a lot of words, just words in a field or whatever. We say, okay, well, these are the answers to these questions, and then we have to do some sort of qualitative analysis on that, but we need to clean up the data in that field first. And a lot of the first thing that you're going to do is remove what are called stop words. Well, actually, the first thing you often do is change everything to lowercase. But then after that, you would put in stop words. And the stop words are kind of like the filler words in English, stuff like and, to, the, and so forth, that don't really add to the complexity of the ideas in the sentence. A lot of times they're very, very important words, but whenever you're going to go do a lexical analysis, these words don't actually help you in the lexical analysis. So what we can do here is we can remove these. So these are the Harvard sentences, which if you're not familiar with this data set, there's a link up above that you can read about the Harvard sentences. But what we'd say is, okay, from these sentences, and I'm only taking, because there's like 700 something of them, I'm only going to take the first 20 to show you examples, but remove all of the times that we see the word and then remove all the times that we see the word to, and then remove all the times we see the word the, and then remove all the times that we see the word of, and then remove all the times that we see the word a. At least this is our intention. Like, it makes sense. We're like, oh, and to the of a, well, whatever. We just pick the words that we want to remove, and we look at our results. And this is where I'm going to leave this as an exercise for you. Okay. So this is where I want to pause this video, and I want you all to take some time and really think through exactly what happened in this code. And remember that computers give you what you ask for. They don't always give you what you want, okay? So take some time, think through these exercises. So right here, notice the results may not be what you expected, okay? So stop words at the end. So we said to remove the, but there's a the right here. Okay, so the stop words at the beginning of the sentence were removed. And now all of a sudden I've got Well, I'm assuming that's the word canoe and that's the word planks, but now we've got something going on here. Another thing you notice, though, is that all of a sudden we've got extra spaces in these sentences. Okay, spaces matter. They because they are a character, like a space is a character object, and so it would potentially mess up our analysis later. So why are all of these spaces running around? So take some time, think through what you think went wrong with this, and then come up with some solutions. Work with your partners, come up with some solutions, and try them. Try the solutions that you have. And then there's this part right here. What could you do? What could you modify up here or with your solution to help remove some of those extra spaces? All right. And that'll be all for today. So after this video is over, work with your partners, work with your neighbors, and try to get a better solution to this problem where you're removing the stop words. All right. And we will come back to this. We'll come back to changing cases in the next video. All right. See you soon.